We know that the series expansion of sin x is x minus x cubed by factorial 3 plus x power 5 by factorial 5 and so on. And series expansion of cos x is 1 minus x square by factorial 2 plus x power 4 by factorial 4 and so on. So with the help of these two expansions, can we find the series expansion of tan x? Let us suppose that series expansion of tan x is a0 plus a1x plus a2x square and so on. We know that tan x is equals to sin x upon cos x. So cos x times tan x is equals to sin x. Now let us substitute cos x, tan x and sin x by their series expansions. Okay, so we get 1 minus x square plus x power 4 over factorial 4 and so on times a0 plus a1x plus a2x square and so on is equals to x minus x cube over factorial 3 and so on. Okay, now here, since this is an identity, therefore on the left hand side and the right hand side must be true for all values of x, right? Now let us see what we get on multiplying these two brackets. So in the constant term, we will obtain 1 times a0, that is a0 or a0 you can say. Now to find the coefficient of x, we multiply the constant term with the term containing x. So 1 multiplied by a1x, it gives us a1. Okay, so we get a1x. Now to find the term containing x square, we can multiply 1 with the term containing x square and here x square with a0. So we get a2 minus a0 over 2 factorial times x square. Okay, in this way, suppose here is one more term like a3x cube. Now if you want to find the coefficient of x cube, so what we can do, we can multiply 1 with this a3x cube. We can multiply this x square with this a1 x term. Okay, so what we get, a3 minus a1 over 2 factorial times x cube and so on, which is equals to this series expansion of sin x, which is x minus x cube over factorial 3 plus x power 5 over factorial 5 and so on. Now since both LHS and RHS must be same, that is both are the expansions of sin x, so we can compare their coefficients like a0 equals to 1, that is constant term is equals to constant term, and a1 is equals to 0, means term containing x should be equal to term containing x, that is x power 1. Term containing x square, I mean the coefficient of term containing x square means a2 minus a0 over 2 factorial should be equal to term containing, I'm sorry, I think there is a mistake. Oh yes, the constant term is 0 and this a1 is equals to 1. Then a2 minus a0 over 2 factorial, this is again 0, and a3 minus a1 over 2 factorial, this is equals to minus 1 by 3 factorial, right? Okay, so in this way we can compare different coefficients to form these equations. Now here we can clearly see that a0 is equals to 0, right? Now if we put the value of a0 over here in this equation, then we get a2 equals to 0, right? Now if we put a0 and a1 in this equation, we get a4 equals to 0. So we can observe that a0, a2, a4, etc. means the coefficient of the terms containing even powers are all 0. Now we are left with the coefficients of term containing odd powers, right? That is a1 times 1 equals to 1, which means a1 is equals to 1, right? So now if we put the value of a1 in the second equation, we get the value of a3 equals to 1 by 3. Similarly, if we put the value of a1 and a3 over here, we get the value of a5, which is equals to 2 by 15. And similarly, we get the value of a7 equals to 17 by 315. Now we are not getting very eye-catching or very common pattern in these values, but what we can do is that what we get over here is that a pattern uh, which is followed by these coefficients, by these coefficients in these equations. Okay, so here see, here we have plus a3, we have plus a5, we have plus a7, and after that it is minus, plus, minus, plus. That is alternating signs, right? And in the denominator, all these factorials are of even numbers, right? So we can write a similar equation for a9 also. What we will do, we will start with a9, and here is a plus. Then we can write minus a7 over 2 factorial, then plus a5 over 4 factorial, then minus a3 over 6 factorial, and then plus a1 upon 2 factorial, and this will be equal to plus 1 by 9 factorial, right? Since here it is minus, then plus, then minus, so and now we will get plus. So with the help of this equation, we can find a9, and hence tan x is equals to x plus x cubed by 3 plus 2 by 15 times x to the power 5, and so on. Don't forget to like and share our video, and for more such videos, subscribe to our channel Brain Exploders. Thanks for watching.